Hi there, this is section 1.4, solving absolute value equations. So let's just go through your video note sheet. So our vocabulary is absolute value, empty set, constraint, and extraneous solutions. Our objectives here, we're going to evaluate expressions with absolute value, and we're going to solve absolute value equations. So remember, we learned the difference between an expression and an equation already. So what does absolute value mean? Let's start with that. Let's look at the key concept. Basically, it's the distance from a number to 0. So if I have the absolute value of -4, I have to go 1, 2, 3, 4 units. So we're measuring quantity and distance, so that's why it's always positive. If I want to take the absolute value of +4, again, it's how many units away. You're counting, you're measuring, so it's always going to be positive, 1, 2, 3, 4. So if you were measuring a desk, you can't have a -3 feet, could you? So it's quantity. So same thing with absolute value. It's the distance from a number to 0. So basically the rule says if the absolute value of A is equal to A, then A is greater than or equal to 0. And if the absolute value of A is equal to -A, then A is less than 0. So basically they're just saying the absolute value of 4 is equal to 4. The absolute value of -4 is also equal to 4. So let's look at this first example. Let's evaluate an expression with absolute value. So remember, it goes into the grouping symbols in the order of operation under P for parentheses. So again here, what are we going to do? We're going to substitute in for 7.5. Sorry. Let me get back here. So we're going to have 8.4 minus the absolute value of 2 times -7.5 plus 5. So we have absolute value here, so we're going to do inside of parentheses first. So 8.4, this minus is outside, this becomes -15 plus 5, which is equal to 8.4 minus the absolute value of -10. So now we have to do the inside of the absolute. We're not done. So now we can take the absolute value of -10 is +10. We have 8.4 minus +10, which is just simply 8.4 minus 10, which equals -1.6. So pause the video, try guided practice 1A and 1B on the next page, on your page 2 of your video notes. Okay, so let's look at this real world example. We can solve an absolute value equation. So it says in tennis, this is a tennis one. A standard adult tennis racket has a 100 square inch head, plus or minus 20 square inches. Write and solve an absolute value equation and determine the least and greatest possible sizes of the head of an adult racket. So we're going to stick to this basic core pattern formula that says the absolute value of x minus c equals r, where c is the central value, the value in the middle, and r is the plus or minus. That's your range, your top plus if it's plus or minus 5, so you add 5 to that middle number and you subtract 5. Okay, so what do we have here? So we look at our problem. We've got our middle number is going to be 100 because that's the average range of a tennis head is 100 square inches. Then it's plus or minus 20, so we're going to equal it to r, so r is going to be 20. So now that we've got this, we can solve for x. So we have to isolate the absolute value. There's nothing plus it or minus it outside of it or times it. So I take x minus 100 equals 20, or x minus 100 equals -20. So let me step back for a second. If we go back to when we had the absolute value of 4 equals 4 and the absolute value of -4 equals +4. So if you go back to your book and you look, and they show us this right here, that same problem. So let's went too far. So basically, we're saying for any real numbers, a and b, where b is greater than or equal to 0, so we said if the absolute value of a is equal to b, then a equals b. Or negative a equals b. But right, because the absolute value of negative a is also b. But they can rearrange it using algebra and divide both sides by a negative, and you end up with a equals negative b. So that's what we do here. We take the absolute value, equal it to its positive, or equal it to its opposite. Now we solve. So we just solve the equations. We add 100 to both sides, and we get x equal 120. Or we're using our properties of equation, x equal 80. But we have to check them to make sure that they both work. So if we put these back in here, so the absolute value 120 minus 100, does it equal to 20? Yes, it does. So that is a true solution. And we do the same thing here, and we say 80 minus 100 equals 20. Now this is going to be the absolute value of negative 20, which is 20 equals 20. So both of our solutions work. Okay, what we have to be aware of is we have to be aware of an extraneous solution. So before you do that, let's pause this. I want you to solve guided practice 2A and 2B. You basically are solving for the absolute value. Isolate the absolute value, and you equal it to positive, or you equal it to its opposite. Okay? Now, a constraint. Our next two vocabulary words are going to be important. So constraint is basically just a condition that a solution must satisfy. That's all, meaning you're taking the right steps. So sometimes when you solve an equation and you've done all the steps correctly and you get a solution, but then you take that solution and check it like we did and put it back into the original and you get a false statement and it doesn't make the solution true. We call those extraneous solutions. So we always, when we do absolute value, must check to make sure that we don't have one or both extraneous solutions. Okay, so let's look at an example where that does happen. If you look at example 3 on our sheet, right here. So we take the absolute value of 3x minus 2 plus 8 equals 1. Okay, the first thing we have to do is we have to isolate this absolute value. We'll have a plus 8 on that left side, so I need to get rid of it. So I'm going to minus 8. I'm using properties of equation. Just because an absolute value is still an equation, those properties still exist. So this is going to be 0, so then I'm left with the absolute value of 3x minus 2 equals negative 7. So let's think about this. Does it matter what I put in for x? It could be a small number, a big number, a positive, or negative. Whatever this number is, only minus 2. We're going to get some value. The absolute value, even if it's negative, the absolute value of a number is always positive. So is there any way, any number that we can put in for x that would make this absolute value equal to a negative? There's not. So if you have an absolute value equal to negative, guess what you have is no solution. When we have no solution, we say we call that the empty set. That's our other vocabulary words. It's the empty set. Basically means there's no solution. And there's two other ways to write it. You can say no solution. You can write the word empty set. You can use this little symbol, or you can put empty braces. This all four of these are ways to write no solution. So pause this video and work on solving guided practice 3A and 3B. Make sure you isolate the absolute value first and then equal it to itself and then to its opposite. Okay, so let's look at this next one, example 4. We have one solution. This one's a little bit more complicated. Again, our problem, let's write out we start with writing out our problem. We have the absolute value of x plus 10 equals 4x minus 8. It doesn't matter that I have an x on both sides. All I care about, this is an absolute value equation. You need to isolate. It's not times anything. It's not plus or minus anything on the left side. So we've isolated. So now we take it and we equal it to itself, or we equal it to its opposite. Now you have two terms on the left side. So I'm going to put it in parentheses to remind me I want the opposite of the entire right side. So let's start over here. We're going to just use our properties of equation and we're going to solve, and we get negative 3x plus 10 equals negative 8. We're going to minus 10, we get negative 3x equal negative 18. We're going to divide both sides by negative 3, and we're going to get x equal 6. Now here, before I can go on, I'm going to need to do what with this negative? You need to distribute it, because this implies times everything in here. So we have negative 4x plus 8, because negative times negative is positive. Now we just simply solve the equation using our properties of equation. This cancels. We have 5x plus 10 equals 8. Going to minus 10 from both sides. I get 5x equal negative 2, x equal negative 2/5. So first thing I have to do is I need to check for any extraneous solutions. So I'm going to plug this back in here. So the absolute value of 6 plus 10 equals 4 times 6 minus 4. So that's 24 minus 8 is going to give me 16. Then 6 plus 10 is 16. The absolute value of 16 is 16. That is a solution. So I'm going to stick with this. This one's good. Right? Oops. Oopsie. That one's good. So now I'm going to come over here and I'm going to put it negative 2/5 in. So I'm going to squeeze it in over here. The absolute value of negative 2/5 plus 10 equals 4 times negative 2/5 plus, minus 8. So if I change this to 50 over 5, I get 48 over 5. The absolute value, which is 48 over 5. Then I'm going to come over here. This was negative 2/5. So I have a negative 8/5 minus 8. So I simply, since they're the same sign, I'm going to add them. So I get negative 8 and 8/5, which this is 1 and 3/5. So that's going to be negative 9 and 3/5 by 45. 48, so this equals to negative 48 over 5. Do these two equal? No, one's positive, one negative. They totally have different values. So these don't equal. Guess what this is? It's not a solution. It's an extraneous solution. So my only answer is, for this one, x equals 6 would be the answer to this problem. Stop the video, do guided practice 4A, 4B, check your answers, and we will see you in class.